record this again. Okay, so I think functions you are familiar with already. Only thing is that probably the power or the capability that comes with function need to be further explored, and that is what we are going to do in this session. So think about a modern smartphone that you can use to surf the net. So I mean, when you surf the net, you probably provide some keywords to search for, and that eventually displays some list of pages, and then you can click it, or you can provide a URL, which is like you can type the URL, which is the web address, and that will get you the desired page. That, let's say you want to book ticket, and you can use some app, which there are many apps nowadays like to book this ticket, which eventually contact or do booking through IRCTC. So you need to provide the input data, which is like the user ID, password, the booking information about like the travelers data, and then the payment information, and then in the output you get the ticket. Similarly, you send the emails and you take photos. So you know that these are the tasks where you provide some information as an input, and you get some information as a result of that exercise, right? So you can see like there are many functionality, that different kind of functions involved here. Right now, we are not looking them as from the perspective of coding and Python coding, where we are targeting to discuss about the functions that we can write in Python. But these can be called as more abstract functions, because each of these tasks take some inputs and provide some kind of output. So it may not be one single function, it may be some kind of hierarchy of the functions or some processing which is going on, but the whole idea is everything that we do in this world is in a sense of like we have some intention to perform some job where we provide some input from our side, our effort, and then we get something in return. So this is like nothing but in a sense like input-output relationship. And you know that in the mathematics, like there is a function which is very similar to what we are trying to achieve here. So in maths, what you say that you say that y equal to fx, right? And very interestingly, this x is nothing but the input, and the y is nothing but the output, and therefore this function is nothing but takes the input, perform this computation or the operations of whatever this function is. So the computations are performed as per this function, and eventually we get the output, right? So these functions are also like can be thought of like the mathematical functions or more abstract functions that we use to perform over our mobile or web applications, where we may be interested to buy some item over some e-commerce store like Flipkart or Amazon, and eventually we place an order, right? So there's something which is going on in an abstract sense, but under the hood there are functionality, right? The functions which are performing their job, and eventually you get your things done. So functions are typically, you can say that these are very much building blocks of problem solving, right? So when we have some job in our hand, right, then what we do is like we figure out that what are the different things to be taken care of. So we divide this problem which we need to solve into smaller problems, which is called divide and conquer approach. So we divide it into smaller parts, and those smaller parts can be further divided if it is not good enough to be solved at one go. So this dividing can continue to some extent till we reach to a point where we can solve those subdivided problems, and then we can combine their solutions to get the solution of the original problem. That was the divide and conquer approach. And it is like quite commonsensical because we are using it, whether we know it or not. We are solving problems, our own problems, or whatever problems are given to us, we are solving based on this divide and conquer approach. And you'll find that this is very much aligned idea that how we like write our code in terms and organize our code to get this solved, right? So there will be many advantage, or you can say the implications of using functions. What is a function? A function is an independent, self-contained unit of program. So you might have already seen some functions. You might have written some function, as we have discussed in the previous lectures. And I have personally encouraged you to write those functions, but that, as Dan has figured out, and while you were writing the functions, probably you might be facing some problems regarding returning from the functions or having proper indentation, that what makes the body of that function, what is inside the function and what is not the part of any function. So you might be struggling for some time. Some of you or many of you already sorted out those kind of issues, but some of you might still be facing. So I hope that all those things we will be taking care of in this session, and we will also, and in the afternoon session, and after today, you should be confident of using those functions, and you'll see that there are more power that comes with this function. So the more flexibility that we can exercise with functions, and that is what we are going to do today. So a function is going to have a name, which is how it is going to be identified with. Then it is going to take inputs, which is nothing but we call them as arguments. Then it has a body, which is like the body of the code, which is like the indentation part, which is like, that there is a vertical alignment inside the function. So all that code which is aligning to that vertical alignment, that is that indentation, forms the body of that function. And then we have that return statement, right? So sometime you'll see that we in some function we may not write a return statement. Still, that function is perfectly all right, but it's not returning anything. So it is doing some duties, I mean, performing some tasks, but not returning. That is perfectly all right. Or in some cases, or many other cases, you'll find that it returns some value, and we'll see that it can return multiple values at the same time. So how one value or multiple values can be returned from a function, not just one value. So maybe by this time we are more familiar with returning single values, but how can we return multiple data, multiple values from a function, that we are going to discuss today.
Excuse me, sir.
Yes, please.
Sir, I have one doubt, sir. I am facing some problem relating to screen share. Sir, have you shared the screen? Sir, I am not able to see.
Yes, sir, I am also not able to see.
Sir, I have
Yes,
raised my
sir, I
hand
am
also,
also.
is for everyone,
more
I
than
guess.
5 minutes, sir. You are not.
Sir, it's
Also.
visible to me.
Same, sir.
The
Sir,
screen
only
is visible.
first page is visible. It's not changing.
Yes, sir. It's not changing.
Yeah, sir, usually, yes, sir.
So still not changing?
Sir,
No,
only
sir.
first page is visible.
Only first
No,
page
sir.
is
No,
visible.
sir.
The first page is visible.
So you
So
can reshare
whatsoever
the
you
screen.
have. Yes, sir.
Okay.
Now it's visible, sir.
Is it visible?
Yes, sir. Now it's changing, sir.
Yeah, now it's visible.
Fine.
Yes, sir, it's visible now.
Okay.
यस सर आपने सर जो भी पढ़ाया सर समझ में आ नहीं पा रहा था हैंड भी रेज किया पर आपने सर देखा नहीं सर
Thank you very much for this, because yeah, it was issue from my side only. So thank you very much for pointing out, and I hope that now this is resolved. So I can go through very quickly those things which we have talked. I mean, I have taken this example of a smartphone where we do many exercises. And the point was, I was trying to make here that we can carry out different kind of functionality in terms of like surfing the net, booking of tickets, sending mails, taking photos. We can talk using those smartphone, and each of these can be think of in a broader sense, in an abstract sense, as functions, right? Which is typically available for you to get exercise, because you provide some inputs, you get something done, and you get some output, right? So you get the results of that exercise. So basically, function is a very abstract idea, right? And which we can take at any level of abstraction. And when we design the problem, we can figure out that what are the main part of the problem or the subtask of this task, and then we can solve these tasks or subtasks and then combine their solutions to get the solution of the original task. This is how we can solve problems, like dividing our problem to smaller problems, solving them. So a function can be thought of like having a solution of a small problem, right? And therefore we may require many functions, and we can combine these functions in some problem solving way, where we can make use of all these functions or whatever needed functions and solve that part and eventually solve the whole problem. So functions are a very useful idea to solve problems here, and not just like our real life problems which we solve by this approach called divide and conquer, dividing our problem into smaller problem. Similarly, the code problem that we have in our hand in front of us, we can divide that code problem into small part, can write one function for each of this part, and can use these solutions as and when required while we solve this main problem. So functions are typically, you can say that it is a building block, right, of organizing your solution of your problem. So these are going to be useful chunks of code, a small code, and which you can use one or more number of times. So this is also allows us to reuse these functions, right, as and when they will be required. And this is how we partition the whole functionality of our code, which we need to write as a solution of that problem, into those functions. And these functions can be sensibly then used in other functions or in our main code as and when it is required, as and when we need them, we can use them. So that's what the idea of functions. And I hope that by this time, because we have already started using functions since the beginning of this course, and I've encouraged you to use them in your writing, in your code, as and when it is possible. But today we will take explicitly more detailed look on those functions and their capabilities and the varieties by which we can define them, we can use them, we can pass information to function for computation, and can get the information from those functions back to the, like, from wherever we have called this function. So functions, how we identify functions, it has a name and set of arguments, which is nothing but the inputs. So we have name is like for name, which will recognize that the name of the function or this is identity. Then arguments are nothing but the inputs which we share with that function. So we pass to the function. When we call that function, so we need to put those values, which are nothing but the arguments of that function. In other words, we say that we supply those values to that function. And then there is a body, which is nothing but the code of that function, which gets start executing, running, and finally the function return. So sometimes it may not return also explicitly. So this return statement, which we have seen at the last of function body, sometimes it may not be there. So that is perfectly all right, because when we say return, then it returns specific values to the to a place where it was called, right? And if there is no return statement, then the function just finishes by doing some operations as per this code, but it doesn't return explicitly. So that is perfectly all right. Sometimes we in this language of programming, we say this, that the function that doesn't return is a kind of called as void function. It does some operations but doesn't return explicitly, because nothing is to be written at some cases, and therefore there is no return in those cases in that function, right? So this is what we need to know about, like, functions, a function organization, or the various part of the function. So as I said, function is the most basic unit of reusable code, and we are reusing this code. For example, this print statement many times. Like, all of us have used this print statement hundreds and maybe thousands of times now, right? That we have written so many print statements. So what is this? I mean, writing print statement with print function, making use of this print function is like using that function again and again. And that's a very clear case of this example that we are reusing a code, because there is a function defined print somewhere in the language support itself. So this function is an implicitly defined function, which is like a function defined inside the Python so that you can directly use it without writing yourself this function. So in a sense, like you are reusing the code of that function every time you call that function, right, in your main program. And we have seen these functions, like for example, input function also, and we might have used them many times. So that straightforwardly suggests that we can write once a function and can use it hundreds of times, infinite many number of times later on, right? So that's a wonderful aspect of reusing code. I mean, not doing everything from scratch every time, but rather than building upon on our experience or on our efforts or somebody else's effort who has written those functions, and we are building on the top of this so that we can quickly develop the software. Right? That is the whole idea about this reusing of the code, right? And it's not a bad thing per se. If somebody has done something already for you, why you will be spending a lot of time writing yourself that part and then going further? Why not you take that part and start building further? So it's a kind of a ride that you get a free for free, and you reach to that destination very quickly, and then you take further travel from that point of time. So you can go much further rather than if you start like walking from the original place. So you see, that's very much one of the best practices in coding, that if there are functions available and which you can use, so you should be using them rather than writing of your own. It helps in better organization of the code. That's again true, because we don't write a very long, lengthy code where everything is written in one single chunk of code. I mean, maybe 100, maybe 1,000 lines of code is written one after another, and you every time scroll from top to bottom. And if there are errors when you run this program, then you struggle with that error because it can be anywhere in those 1,000 lines or even 10,000 lines. So it's a very bad idea of programming that if we write such a large code. So one of the best practices in coding is write small code, which is in the form of functions. And once you will be familiar with objects, right, object-oriented programming, then the objects, then you will see that we will be writing different objects rather than these functions, and then using those objects working for solving some problem, right, in your program. So since we are not focusing object-oriented programming in this course, so I'll keep aside that object idea. But this function idea, I mean, object idea a little involved than the function, but it definitely has an important component as function. So function is always going to be very useful. In this language, for example, Python, for the part that we are covering, functions are the building block here, the basic unit of code and reusable code, in fact. And in programming language like C also, which is a functional oriented programming, or which is also called a procedural oriented programming, where there is no objects per se. Again, functions forms the basis of programming, basic building blocks of those programming. Okay, so this reduces the repetition or redundancy. So you don't write that kind of code again and again in your main code. Rather than, if you know that I will be using this code at different times, same code, but maybe for the different data which is being handed over to that code, and so different output will be generated. So this is clear a case of defining that bunch of code as a function, and then passing those values which will be consumed by this function. When I say consume, means that the code of that function will be using those values, will be performing computations based on those values and generating outputs. And that outputs will be then we can receive in the main code. And this is how we can use those. We can write those codes as functions. So it reduces the size of the main code. because then we can figure out or factor out some part of our main code as functions. So the main code will reduce, because then at the appropriate place in the main code, then it will be just a call to that function. And in one single statement, this whole body of the function will get executed, which is exactly not the part of the main code, but now we have defined as a separate code. So this makes the code more modular, more maintainable, because now you know that this, if there are errors, you can track it down and figure out that if it is an error encountered in a function, or it is an error in somewhere in the main code. So you can quickly do a debugging, and therefore your code is going to be more maintainable, more readable, understandable, and making changes in the code will be simpler and less buggy. And that is again like something which is like related to software development stuff, that there's some best practices of when we write software, big software, where we will be writing this code in a form of this modular code. Eventually, if it is a procedural oriented or function oriented, then it will be the function, or if it is an object oriented, then it will be more than functions. Each of these, like, which is called objects, and therefore it will be a collection of objects, which will be, again, I will not go there because that is not the part of this course, object orientation. But functions will anyhow every time will be needed. Even if it is an object-oriented code, objects will have those methods, and those methods are nothing but the functions that we are discussing here. So if once you are familiar with these functions, then moving to object orientation will be slightly straightforward than directly going through those objects, right? So it will be good that we are making slow or steady progress, and we'll be more confident of our skills, our understanding of those programs or coding. And you will see that very soon we'll be much better off in solving problems using language like this Python, using only functions, or we can also use objects and can provide a solution. As I already said, in object orientation, these functions are combined with some data to form objects, right? So objects are going to be a little more than function. They will be having some features, some attributes along with this method, which is like functions, and that will be called an object, right? So I will not go there. As I said, we'll continue to deal with this idea, which is a much simpler idea, very useful idea in programming, which is functions. In procedural programming language like C, they form the basic building blocks of the code. And the kind of programming that we are also learning here in this Python programming, we are not making use of objects, rather than we are will be using functions. So for us in this course, these functions are going to be basic building blocks of the code, right? Though Python support object orientation, and therefore one can also use objects in their programs, right? They can define objects by themselves. But yes, I hope that you will be able to do that part. But for now, we'll keep things simple and elegant, discussing this, right? So functions, type of functions, we have seen function, inbuilt function like print and imports, and those functions which are like language defined, inbuilt functions, which we call them. Then we have user defined function, which is the topic of this week, that we will be writing our own functions, right? And then using them in our own program. That is how we will then be comfortable to write bigger size of code in terms of, let's say, many functions. So we have written 10, 20 functions, and we are making use of these functions within function code, or maybe in our main code. And this is how we are going to design the solution of the problem in terms of like a modular decomposition and functional decomposition of the problem, and therefore writing our code using those functions and making use of those functions in our main code eventually. Right. So syntax you are already familiar with. We have this def keyword, then we have this name, which is an important part of the function, then the parameter, which is arguments. I set arguments of the functions, which is like the one or more values, or even like it may be like no arguments are provided. So maybe a function which doesn't take any input but does some task. So depending upon the purpose it would like to serve, we will have those inputs, and then we have finally a return statement, which will return the output of this expression. So we'll have, so ideally this will return one value, right? But we'll see that how we can allow this one value to have multiple values as a ingredients of that one value. And that is also like, so in a sense, like we are getting back multiple values from this function, right? This is what we're going to do. And the rest of these things in between are going to be the function body. And there is one interesting thing which is called function docstring, which is like 3 quotes, three opening and 3 closing quotes, where you can write some string, some text as a function string. So that is encircled in these 3 quotes, opening and closing, which we call as function docstring is nothing but the help code. So if you type help and with the name of this function name, which is the name of function here on your command prompt, you will get this docstring printed, which is nothing but, so here this docstring is nothing but the kind of help message which will be displayed when we request help on this function name. So if you don't write a docstring, there will be nothing will be displayed, because this help function automatically search for a docstring statement, which is a text statement here, which is encircled in these 3 quotes, 3 single quotes on left side and the right side, and whatever is this is the statement or the message that we put here is going to get displayed when you write this command on command prompt, right? So you will get all this data, all this information getting displayed here. So this is just for the help of those people who probably are the user of this function, and they would like to know that what this function does, and the designer of this function has written this information that this is what the function does, right? So this is like to get you familiarized and get to you the help on those functions which you have not written, but somebody else has written this. Now this is an example, very simple example. We have seen that we read this code and we find the maximum of 3 numbers, right? And we have seen that how can we convert this code into a code which will either take 3 values or maybe like take 2 values, and we can actually in an interesting way can use this function which takes two argument and provides which one is the bigger one, and using this we can solve this problem of finding maximum 3 number. So just look at here, we can convert this whole code in one single function code which will take ABC as 3 inputs, or I can write a function which will take 2 values at a time, so A and B, and return which one is greater than the 2 number in these 2 numbers. And then I can use this function to multiple times to find the maximum of 3 numbers. And the idea is very simple. What I am going to do is in the main code, I'm going to call this function by passing this A and B 2 values. So I'll get a intermittent or intermediate value which is among the 2 number, which one is greater, and then I will compare this number with the 3rd number and I'll get the maximum number. So this 2 line of code get me which number is the largest number given the 3 numbers. So you can see, right, that it's not that this is the better way, or that if we write this whole code convert into one single function which will take 3 values ABC and return the maximum here, right? So here we will be having finally the return part here, and that return then I can call this function. I can have this like maximum, right, ABC, and then so I define here def maximum ABC, putting colon, so this, and then finally return this. So this main code, this whole code which we have written, maybe many of you might have written in the main as a main program. Now we can convert into a function, and then the main code I can ask for ABC first, I can put some values here itself, or I can ask this from the user using input function, and then I can call this maximum function, and maybe I can use this max equal to call this maximum, right? And pass this A, B, C, and then if this will these values will go here and will get executed in this logic, and eventually I will get this max M as a return, which will be stored here, and then I can print this M, which is the largest number among the three number, right? So this is how we can convert some code, which is otherwise we have written as a part of main code. We can convert it as a function, and then that function can be invoked, can be called, can be referred in our main code, right? So this I think you are already familiar with now, and as we have already discussed that various parts of the functions, which include name, then argument, which is inputs, then body of the function, and the return value, right? So in a sense, like there is some input going on, and this function is transforming those inputs, I mean, helping that input to get organized and to get some useful results computed as an output, right? And this output is being consumed by your main program, right? So you see this function does this kind of job. I mean, it takes some input, perform some computation, provide some results, which is further consumed in your main program, right? Or maybe in other functions. So a function may be used inside other function also, right? So it is nothing but in a sense like going to be a functional decomposition, right? So you see, when we define a functions, which is user-defined function, now we are talking about. So we start with this keyword, the name of the function, then this argument. These arguments are called formal arguments, right? These are the variables A and B, and there are two variables here, so we call them a formal argument. And when we call this max function in our main program, just like this, and you pass those values, which is like 6 and 4, or some X and Y, or whatever, like where some X will store some value, Y will store some other value, and we are passing these values to this function, and asking this function to get executed, and results is to be stored back to this variable. So what is happening when we call this function, max function? This 6 will be substituted to A, 4 will substituted to B. So 6 and 4 are actual parameters, whereas A and B are formal parameter, right? So this is how the terminology goes with the functions that we have when we define a function. So within the body of that function, within the definition of the function, we make use of formal arguments. So A and B are formal argument, which is like having scope within the function, right? So they are available. These variables are available to be referred, to be referenced inside the function. So they are valid variable, which have a scope, means they are valid inside the body of that function. And they will remain valid of that. If I call any other function inside this function, then these A and B will also be valid in that functions as well. So we'll come back to this scoping idea a little later. But for now, you understand that these are formal parameter having scope within the function. That is the validity. And then we have this main code where we call this function, but by passing the actual values, which is like the actual arguments. So these are called actual argument. These are called formal argument, right? And when we call this function, so 6 is going to be taken by this A, 4 is going to be stored at B. So A will take value 6, B will take value 4, and the body of this function will get executed. Since A and B are already known, so we can, this piece of code can correctly execute, and eventually we'll get this return statement. You can see here, we have two return statement here, and that is an obvious stuff. Why there are two statements, two return statement? Because you see, this first return statement is with this if statement. So we know that it's not necessary that every time A is greater than B when we call this function, right? So when A is greater than B, then it will return A, else it will return B. So in all cases, whether whatever A and whatever B, it will return and it will return correctly. So that is what we are ensuring, that it will return the correct value, right? And therefore, as we know that if this is true, then the true part of the code, if part will be getting executed. If this is false, then else part of it is going to get executed. And in any case, if the function is supposed to return, it must return. And that's why we are putting the return statement here. So either path, execution path is to be followed by the code, but even at the end of that code, we are having a return statement. So irrespective of which branch it takes, that branch is ended with this return statement, and that is what the correct way of writing the return statement. So you need to know when you write a function, and this function is supposed to return in, right? It is always supposed to return something, right? And if you write some logic, some complex logic, which also include loops and if and else statement, then you have to yourself verify that in all cases function should return. It should not be that only some cases it returns something and for other cases it doesn't return. Then there will be issue, because we are expecting some values to be returned and to be stored in the main program here. And therefore, in one case it will return, but in another case it will not return, then it will raise an error. So I hope you understand the idea of those function and docstring. As I said, this three codes, 3 opening and 3 closing codes. So what it is suggesting, that this function returns maximum among 2 numbers, A and B. So this message, when you type this help, right, help with the name of the function, then you will get this message displayed, which is encircled in the docstring. So this is the good idea of writing this docstring. Whenever we write our functions, we should be writing this docstring. For now, maybe nobody is using our code, so nobody will be using this function. But when people write those libraries, reusable code, and the other people are going to use it, so and these functions are going to be non-trivial. So to understand that what code you are going to use, so what this function does. So how would you know this, right? You don't have the source code of that probably, right? And even if you have the source code, which is like the Python code or some, like you have to read all the code and understand. This is a bad idea. This is one single line, 1 or 2 line, 3 line, some message, useful message about the function, that what this function does, which the designer of that function has inserted in this docstring. Then that docstring will be displayed as those who would like to use that function, would like to know more about this function, simply type help and the name of the function, and will get this help available, this information available quickly, right? Without much of a fuss. So this is very useful stuff, right? Not for us who are the designer, who knows how to how you have written this function and what this function does, but for all other people in the world who are going to use this function, right? Using this function, right? So function calls, right? When you call a function, interestingly in Python, right, a function call is an expression. So when you call a function, it is an expression. Expression in the sense, like just like we have written expression, a function call is also an expression, means it will return something. So in cases where it doesn't return anything, it will return something which is like called as none. I mean, so in cases where it doesn't return explicitly with the return statement, then also there is a return which is like an implicit return, which will be none. And none is a special like variable or special data, you know, in Python, which means nothing. So those who are consumer of this information, if they have written it correctly, then they know that if the function may not return, then it will return none. And I must have some logic to handle that none also, like if I'm expecting some return, right? So function call is an expression, right? And just like, let me give you example, like we have, let's say 5 plus 3, this is an expression. And if I have written a function add 5 comma 3, this is again like getting evaluated and returning some results, right? Some value. So you see functions, why not function to be an expression? And it's at first instance, it looks like a counterintuitive. The function is something which is like code block. It does something, compute something. It does a lot of computation, maybe. And how come it should act like an expression? But looking to the way the function is being used in here, like in Python, that it performs some operation and it returns most of the time with the statement return. At the end of the function, you get something returned. But even if the return is not there, then also like this function is going to return, because function are expression in Python. So they will anyhow going to return. So that return can be captured in some variable or in some other expression as a part of expression inside like the main program or in some other function code, and can be used accordingly. So you should be understanding this, and should be careful about that. When we call a function, it's a kind of evaluating expression, right? Which will have some results to return back, right? This is some more example to tell you that you can actually, when the function call or expression, you can call this max 5.3 and min 5.3, and this will return some value, this will return some value, and this whole will become again an expression. So you will see that this is how your code blocks or code statements where we are dealing with expressions, function can become a part of expressions. Maybe you will be even more surprised to see that functions can be passed as an argument to some other function. So even like since we can pass expressions to functions, right? Some expressions can be passed to some function. Similarly, functions can be passed in that sense, right? So this becomes so flexible idea in programming. The functions, not a very different kind of construct, but actually it's an expression, right? And it substitutes for an expression. So maybe at this point of time, it sounds a little complex. Don't worry. Just understand and keep this in your mind. The functions calls are expressions, right? And therefore, it can become a part of expression. It can be evaluated and written as a value of an expression. So this is like, yeah, you should be remembering this. Now, some more stuff about functions. So there are something called keyworded arguments or non-keyworded argument in function. I'll take straightway some example to suggest this point. Let's say we have this function print name. It takes 3 parameters: first, last, and initial. So it is printing a name. It takes first as like first name, last is like last name of the person. So basically this function intend to print the name of a function. Now this function, this print name function either print the complete name, which is the first name and last name, and we don't have a middle name here. So you can put the middle name if you wish, but we are considering that a name is consist of 2 parts, first name and last name. And this initials, this another variable here in this function. It's a Boolean variable, which when it is true, then we'll say that it will put the initial. So for example, my name is Atul Gupta, right? So my first name is like Atul. I'm going to call this function with first substituted with Atul. Last is substituted with Gupta, and let's say initial is like true. So I give this 3 value, right, when I call this function. So what I'm asking here, that you should print initials, my initials, and my initial, if we need to be put, then A dot G dot, right? So this is what I mean when I need to print my initials. So in this function, what I am asking that this function either print my complete name or going to print my initial a dot g dot. So how come this function will do these two things at different times? And this is controlled by this third variable, which is a Boolean variable initial. And if it is true, so this is what the code is. If initials, that is, if it is true, then print this part, which is the initials, or else print the complete name, which is first and last, which is like Atul Gupta. So this is going to print this complete name. So this simple function here, simple example tells you that we have got these arguments here, 3 arguments. Now, what is the keyworded argument here? What do you mean by keyword argument? And we know that these are 3 arguments here. So we will come back to this point very soon, keyword argument. But for now, you understand we got 3 arguments: first, last, and initial, right? So I can call this like this print name function with these parameters. So I give these 3 parameters: a cat, for example, institute, and false. When I'm giving this 3 values, which is supposed to be received by this function, so a cat will go as first, institute will go as last, and false will go as initial. So when it is false, that means not true. That means it will come here and it will print the first and last. So it is going to print first and last. What is first? A cat's. And what is last? Institute. So it is going to print a cat's institute, right? There is a comma here. So this comma will make the one space available here while printing. So that is what the print statement is, which you are familiar with. So we'll get this output as a cat institute. And if instead of, if I call this function with these parameters, then it is true, then it will print the first letter, right, with dot, first letter with dot, followed by this plus the last letter and this dot. So a dot g dot, right? So is here a dot I dot. If a cat and an institute are the first and last, then the output is going to be a dot I dot, right? So this is also fine. Now comes the third invocation, third way of invoking this function. So here I put last equal to institute. So here it is very interesting. I'm referring to this last, right? And last is here, right, inside the body. So that means now when I call this function, I am aware of the parameters name, this formal parameters, this is like first, last. So I'm aware of, so I can refer this last here, last equal to institute, and initial is equal to false, and first equal to cats. Now you see the parameter that we were passing here, right? So the parameter that we were passing here in the previous example, directly those values, right? So we have passed a cats, institutes, and false, and that order has to be maintained, that this a cat by default going to be substituted for the first argument, the institute is going to be substituted for the second argument, and false is going to be substituted for third argument. But when if we use this way of passing the parameter or the passing the values to the function, that where we also make use of this argument, then we call as this keyworded arguments. So here we are making use of these arguments explicitly in the function call itself with their formal parameter name as last equal to institute, initials is equal to false, and first equal to a cats. So we have done this way where we haven't made use of keyworded argument. We have directly passed as arguments, right? And they will take their places or values accordingly in that sequence. But now this is possible. I mean, this is another way of calling or passing these parameters values by referring to the formal parameter names, and which then we will call as keyworded arguments. because we are using these keywords, which is nothing but the formal parameters name in the function definition to be explicitly referred in the function call, and then they will become as keyworded arguments. So these arguments, this is one argument, which is the last equal to institute, initial equal to first. This is second keyworded argument, and this is like third keyworded argument. And if I pass this way also, then I'll get no error. I'll get an output where now you can see here in this interesting function call that I'm passing the second value here at the first argument, right? So last, which is the second parameter, second formal parameter in the function definition, but I am referring it here in the first place. In fact, I can do a jumble here. I can refer any parameter here with its name to be displayed or to be referred anywhere in this list of parameter when I call this function, right? If I use the keyworded argument. If all of them are keyworded argument, I can call them in any order. So I need not to call this as first. I mean, I need not to write this here and then this is the second place and this as the third place. Though, if you are referring to their name, which is like you're using keyworded argument, you can refer them in any order, right? That will not make any difference because we are explicitly suggesting that the last will take this value, which is unambiguous. Whether last come here or last come there or wherever the last is, last will take this value, initial will take this value, and first will take this value. So when this is unambiguous, there is absolutely no issue. You can put them in any order and call this function, and you will get, because initial is false, again initial is false, that means the else part will get executed and you will get this results display. Similarly, I can do this also. I'm passing this first parameter without a keyworded argument, but the second parameter here and the third are passed as keyworded argument. Now here there's a very interesting, right? So you see, there is more flexibility in how do you pass parameters, how do you call that function. And this is again a valid call, function call to this print name function. Here, the first value that you are passing is not a keyworded argument. It is a non-keyworded argument, because we haven't associated with this value with this keyword first, right? It's straightway one value. So by default, this will going to take as the first parameter, right? So it will substitute for the first parameter, and remaining of the keyworded arguments are passed through their keyword value pair. So this is the keyword, this is the value, this is the keyword, this is the value. So this is like these pairs, keyworded arguments are passed, so they can come in any order again, as we had seen in the previous example, and therefore that is perfectly all right. Now here one more thing that you need to remember, that we have now mixing here non-keyworded with keyworded argument. And therefore, we need to follow certain protocol, certain rule here, so that as to not getting this messed around, right? So what we are going to do, so all non-keyworded arguments should be preceded before all keyworded argument. This is what the protocol is. This is what the disambiguation rule is. If we follow this rule, then there is no disambiguity, no ambiguity in a sense, like, and it will be completely clear that all these non-keyworded will be sequentially going to take their values assigned, right, and to those respected formal parameters. And for the keyworded argument, which will come later in this parameter sequence, right, they can come in any order because they are combined with their keyword value, a keyword with the value. So that is unambiguous, that whether some of them coming first and some of them coming in some other order, that is perfectly all right, because we have the correct matching of the keyword with the values, right? But for all non-keyworded argument, they should precede to all of those keyworded argument. Right. This is what you should. If you don't follow this rule, then you are going to get an error. So parameter passing, where formal parameter is bound to actual parameter using formal's name, right? Formal parameter name. And we can mix keyworded and non-keyworded argument. You should be careful here when you mix them. Non-keyworded argument precedes over keyworded argument. So if there are 10 arguments in a function, right? It's unlikely that we pass so many arguments, but then when you start writing bigger functions, which will do a lot of work, then you'll find that we pass many values, and maybe like some with non-keyworded argument, some with keyworded argument, and very soon we'll see some with the default argument also. Then you should follow this rule, which is like all non-keyworded argument, they should be precede over a keyworded argument, right? Non-keyworded argument are matched by the position, obviously, because they will be passed before the keyworded argument in that sequence. So they should match by the position in the formal list of argument in the function definition. So they are matched by the position. Order is important here, very important, right? When these are all non-keyworded argument. But order of keyworded argument is not important, that we have seen this example also, right? Another interesting thing that we can do while we use functions is we can make some of the argument as default value. So for example, with the same example, if we continue with this print name function, which is having 3 parameters, first, last, and initial, you know that here I'm writing this initials as false. Now, very interestingly, I have made it false. That means by default, initial will be false until unless we explicitly in the function call make it true. Otherwise, it will remain false. Even if in the function call, if we make it false, since it is by default false, and we are also passing as false, so that it will remain false, and this perfectly all right. Right. So how default values can be useful, right? So here you see now I can call this function with 2 parameters only. So in the last example, as you have seen, we have used this with the three values, right? And if you pass 2 values only, then it will complain. It will generate an error, right? If we use this function without a default argument. But if we use this default argument, where we have set this initial is equal to false, that means we are assuming here as a designer of this function that this function can be called without specifying this initial. And by default, this initial is false. That means this function is always by default going to print the complete name, the full name, right? This is the default behavior of this function. So whenever your function, if you think that most of the time our function should behave in this way, so some parameter we can put some default value, and those values will allow for the default behavior of that function to delegate, to get exercised, to get executed. So in that case, you can make the work of your client, which is the user of this function code, right, can simply use this function without giving a lot of information. So for example, here, if I give only 2 information, a cats and an institute, then it will run correctly. If I have set this initial equal to false, and if I don't set this as a false, then this will generate an error. So if it is not with the default value, then this will generate with the error. And if it is with the default value, then this function call is correct. There is no error, because default this initial will take false, and therefore all the 3 parameters are initialized when this function was called, and it will completely okay to execute this function without an issue, right? And I can also call with giving some value as initial is equal to true. So you know the default it is false, but if so this is overwriting your default values. So if I pass some specific values right from my side, then this will take over. This value will take over. So when I I call this function using this set of arguments, then the initial will become true. So this default will be overridden by this true, and this function will be then will be called, and you know that when it is true, it will be nothing but the initials will be printed rather than the complete name. And as you know, we have seen this kind of thing that you can call them with the keyworded argument, so you can change their order if you are using keyworded argument. You know that when we use keyworded argument, we can put them in different orders. But if we are mixing with the non-keyworded argument with the keyworded argument, then you know that all the non-keyworded arguments should proceed before the keyworded arguments. Right? This is what you should be.
Excuse me, sir.
Yes, please.
Sir, can you move to the previous slide once? Sir, I have a doubt. Sir, how will we operate function expression when we have keyworded argument for sir first and initial, and sir non-keyworded argument for last?
No, so as I said, all the arguments when you pass should be in this order only. So you cannot mix this keyworded argument with non-keyworded argument in this order. Are you getting my point?
नहीं सर, ऑर्डर तो मैं रख रहा हूँ, पर मैं ये पूछना चाह रहा हूँ कि सर फर्स्ट को तो कीवर्डेड आर्गुमेंट ले लिया, मतलब फर्स्ट इक्वल टू
नहीं
समथिंग.
नहीं, फिर सेकंड आर्गुमेंट नॉन कीवर्डेड नहीं हो सकता.
ओके सर.
आई मीन ये फिर कंफ्यूजन क्रिएट करेगा ना. सो इसी कारण से लैंग्वेज डिजाइनर ने क्या प्रोटोकॉल बनाया है इसके करेक्ट यूज का, कि आप पहले सारे नॉन कीवर्डेड आर्गुमेंट पहले रख लें और फिर उसके बाद कीवर्डेड आर्गुमेंट रखें, और कीवर्डेड आर्गुमेंट में आप किसी भी ऑर्डर में रखेंगे उनको चलेगा. वो कीवर्डेड आर्गुमेंट किसी भी ऑर्डर में रखेंगे, बट नॉन कीवर्डेड आर्गुमेंट शुड कम इन ऑर्डर बिकॉज दे आर गोइंग टू गेट मैप टू देयर करस्पॉन्डिंग फॉर्मल पैरामीटर. सो उनका ऑर्डर इंपॉर्टेंट है, इसलिए ये सब पहले आने चाहिए और कीवर्डेड आर्गुमेंट जो है वो बाद में आने चाहिए.
ओके सर.
Good. So I think we are finishing on our scheduled time. So I will stop here. Default covered. So we will continue in the afternoon session. I'll take some time in the afternoon session to continue, because in the morning session we had that interaction, and these people from US, I mean, for 2 o'clock, I thought initially that to keep that at 2 o'clock, but then it is around 2 o'clock in US in the midnight. So that is a very uncomfortable time to all of them. So I kept that in the morning time, which is like 10 p.m. at their place. And that I think you won't mind that. And in the afternoon, we'll continue with the slides. So we'll detailed on functions. The functions are very useful. And once you are comfortable with functions, you will find that you are lot much confident about your programming. Once you start writing then these functions and using these functions in different ways, and gradually you will see when we will be discussing about list and other data structures or data types, which is more involved data types. These functions with this function and those data types, you'll find that we can solve much more complex problems very easily than without making use of this function. So obviously these functions are very useful, and we'll put some good effort here. And I request all of you, suggest all of you to play around these functions to whatever extent, right? And somebody has asked in the morning that how I should be good at programming. I should be learning quickly those programming. There is no shortcut for learning programming quickly. But then if you are putting a lot of effort, right, maybe every day, 2-3 hours or 4 hours, I can tell you, like in this particular semester, at the end of semester, you will be very confident and very much like done what it was supposed to be done. And you are at the very much the right track to then choose further course of action, that what specialization you would like to move. Because you will be having wonderful programming skills at the end of this semester. But then every day, some good amount of programming, you should be doing it. Though you may solve our assignment very quickly, maybe a few hours, but then You can make use of internet, right? Searching for problems and looking for codes, experimenting with those codes, a lot of stuff. And if you're doing some course in parallel with this course on Python, where there are more assignment, some of you say the competitive coding where the Python assignments or problems are given, you can start attempting those problems also. This is how you can make yourself engage in more and more coding. And there is absolutely nothing of like fall short of, like, if you put enough effort in this semester, in this course, definitely within this semester, you will be much better off. I mean, ideally off to a wonderful start to your programming and follow-up career. So I stop here.
So you haven't uploaded the recording of last 2 weeks.
Oh, yes, I'll be doing it. Thank you for reminding. I'm sorry for my poor memory, but then, yeah, I'll do that before you.
Sir,
Pattern of midterm exams.
So the pattern of midterm exam is going to be the same as quizzes that we are going to be are being conducted. Only thing is, like, we will add some more kind of questions, which is like short answer type, which will where you will see a code and you will figure out that what is wrong with this code and provide a solution with this code.
So will we get theoretical questions?
Not very theoretical. I mean, programming is not a theoretical stuff, right? So there are not going to be any theoretical question. The quizzes that are going on, half of the questions will be of similar nature, and other half of the questions will be that some code is given and it may have some issues, and you will be asked to find out what is the issue and to provide a fix of that issue. That's what you should be doing.
सर कैनवास पे ही टाइप करना है
One at a time, please.
सर कैनवास पे ही टाइप करना है
हाँ,
Short
कैनवास
answer.
पे ही टाइप करना है। कोई वो जो मिड सेमेस्टर एग्जाम भी कैनवास पे ही होगा। और मिड सेमेस्टर एग्जाम के 2 पार्ट होंगे। एक तो ये which we can call it theory part. जो थ्योरी आप बोल रहे हैं वो यही थ्योरी है कि आपको कोड पूछा है, कोड दिया है और आपसे बोला है कि क्या इसमें गड़बड़ है, या आपको जो quizzes आप already you are going through, so those kind of questions, which is typically we consider that as the theory of programming, which is like specific instances of the problems which we typically encounter and you should be good at. And then there will be a programming part of mid-semester examination, right? So that we will announce separately. So probably by Saturday, we will be announcing about the nature of your mid-semester examination completely.
Sir, what will
sir,
be the
do we
marks,
have
sir?
quiz on Saturday? Sir, do we have quiz on
Yeah,
Saturday?
this Saturday, we will have every Saturday. This is as announced, because this week is not the mid-semester week. So in the next week, we won't have any classes or your lab or quizzes. So that next week is totally dedicated to your mid-semester exam. But before, I mean, this is a prior week and it will be completed as it is supposed to be complete.
Sir, what will be the marks, sir?
What
Mid-sem.
मार्क्स से क्या फर्क पड़ता है भाई, जितने भी मार्क्स पे होंगे, मतलब it is all relative grading. But if you are asking for the contribution of mid-semester examination in your grades, final grades,
Yes, sir. That's
it is 20%.
20%. Right, sir. Okay, sir. Thank you.
Please make the quiz 5 questions available to us on Canvas.
See, I have already made for 4 quizzes. I made them available. I think last week or before that.
Yes, sir. Yes, sir. You have
So I
made
will not be
available.
making them available for every time, right? Because these are typically for your help, but that not for people to download all those questions and then share those things.
No, sir. For the questions we have got wrong.
Yes, sir.
So
We
this we
don't
have
know
already
which
shared.
questions we have.
I mean, I did it, and this was made very clear that it will be available for a duration for 3 hours.
No, sir. For the 5th quiz, last
Fifth
quiz.
quiz.
which was on-
Okay, that I'll do. Okay,
Yes,
sorry.
thank you,
So for 5th quiz, this will be on this Sunday, most likely. I'll announce that again.
Sir, please explain how to use help function for docstring.
Okay, so maybe in the afternoon session, we'll do that. Okay, it's a very straightforward, but still you need to know about it and we'll do it.
So do we have to write it on terminal or sir somewhere else?
No, yeah,
Help.
on terminal. I mean, in the sense like where you write, you write those Python commands, like Python
Yes, sir.
program. Even Python
Yes, sir.
programs you write, right? So you can write this help function.
Okay, sir.
So we'll see some instances of that, right? Okay, so let's stop, and some of you have another class, so please attend this, and we will meet at 2 p.m. again.
Okay. Thank you, sir.
Thank you.